Folks, just on January 28th, Tesla delivered a report card that the whole market couldn't understand, one that even felt suffocating. Revenue was $24.9 billion, down 3% year over year. Although net profit barely held steady, it still slid compared to the previous year. What does this mean? It implies that the engine once touted as a perpetual growth machine seems to have truly stalled. The Tesla that could grow infinitely just by turning on the machines seems to have hit a ceiling overnight. If you only look at the surface numbers, this worry is completely reasonable. Cars are selling slower, revenue is shrinking, and the explosive power of the past is gone. Isn't this the standard script for a manufacturing giant turning mediocre and falling into a zero-sum game? But if you really believe in this mediocrity, you might be making a million-dollar cognitive error. Because when you point the microscope at the details of that seemingly bland financial report, you'll find the truly thrilling signals aren't on the revenue sheet at all, but in those buried invisible bombs. Where did the missing growth go? It didn't evaporate into thin air. Instead, through a massive $2 billion capital injection, it turned into fuel for Musk's private company xAI. Through the newly revealed AI5 chip, it turned into terrifying computing power with a 50-fold performance surge. And through a record-breaking $10 billion in capital expenditure, it turned into mountains of silicon slices piling up in the Texas data center. This isn't business stagnation. This is a mutation of the species. Musk is doing something no professional manager would dare to do. He is actively draining the blood of the automotive business to feed that crisis-born giant infant that hasn't fully arrived yet. In today's AI arms race, computing power is oxygen, and the throat is being choked by Nvidia. So this $10 billion is essentially a ransom Tesla is paying for itself. He is trying to use this money to smash out a completely autonomous path from the underlying chips to the top-level algorithms, thoroughly breaking free from dependence on external GPUs. In this video, let's tear away the camouflage of this financial report. This is a letter of war from Musk to Silicon Valley. Why is the current Tesla no longer a car manufacturer, but a super AI war machine that is frantically devouring computing power to overthrow the Nvidia dynasty? Let's first focus our attention on that controversial $2 billion investment. Investing this money into xAI is essentially Musk keeping core AI capabilities firmly within his own system. This looks like a typical related party transaction of moving money from the left hand to the right, and it even triggered shareholder lawsuits accusing Musk of diverting resources. But in this earnings call, that skepticism was overshadowed by a grander strategic narrative. The two parties signed a deep framework agreement. xAI isn't just taking the money. Its large model technology, Grok, will be officially integrated into Tesla's vehicle systems and the robot brains. This explains why Musk dares to cut ties with Nvidia's ecosystem at this point in time, because he found a perfect puzzle piece. Tesla possesses the most massive data in the physical world and the strongest execution terminals, but it has always lacked a truly top-tier general-purpose brain to understand it all. And xAI's Grok was born to fill this void. Imagine this scene. The future Robotaxi fleet will no longer rely solely on rigid algorithms to plan routes. With Grok support, it will have the ability to understand complex human intentions. It can understand a passenger's complaints, understand the gestures of a traffic cop on the side of the road, and even handle emergencies like a veteran driver. But this isn't enough. Software independence is just the first step. Hardware independence is the hard part. This leads to the AI5 chip that Musk dreams about. On the earnings call, Musk threw out a set of staggering data. Compared to the current HW 4.0, AI5 has improved raw computing power by 10 times and memory bandwidth by 9 times. But in certain specific inference bottlenecks, performance has skyrocketed 50 times over. Do you know what this means? It means Tesla is trying to prove that specialized ASIC chips can crush general-purpose GPUs in efficiency. If this path works, Tesla will no longer need to pay high tolls to Nvidia. Under the future scale of mass production for millions of robots, the cost advantage brought by in-house chips will be at the $100 billion level. This is the real subtext of this financial report. Musk doesn't just want to build cars. He wants to build brains, and even more so, hearts. On the night the earnings were released, many analysts on Wall Street showed extreme confusion about this deal. Their ledger shows xAI's current valuation has soared to $230 billion, or even $250 billion. Tesla's $2 billion investment translates to less than a 1% stake. In traditional value investing logic, this is a deal with extremely low cost effectiveness. Some even question if this is Musk using a public company's money to fund his private empire. However, if you examine this deal from a financial accounting perspective, you've missed the bullseye from the start. This is fundamentally not an equity investment seeking financial returns. This is a technological marriage concerning Tesla's life and death. In the footnotes of the report, there is a piece of information easily overlooked. This investment is not just a financial stake. Both parties simultaneously signed a deep cooperation framework agreement. Compared to that 1% equity, the agreement itself is more critical. According to the agreement, xAI's core asset, Grok, will be systematically integrated into Tesla's in-car systems and the Optimus platform. In other words, the point of this investment isn't equity return, but locking key capabilities directly into its own product system. Why do this? Doesn't Tesla already have the world's strongest autonomous driving algorithm, FSD? There is a huge cognitive blind spot here. FSD is essentially specialized artificial intelligence. It masters driving, understands road conditions, traffic lights, and pedestrian trajectories, but it doesn't understand the world. It doesn't know why that person is waving, or that when a passenger says, "I'm a bit cold," they hope for the AC temperature to be raised. Grok, on the other hand, is the embryo of general artificial intelligence. It possesses a deep understanding of human language logic and common sense. Regarding this, Elon Musk used a thought-provoking phrase on the earnings call. In the past, the two were more like ordinary partners, but now they have entered a stage of deeper binding. This means Tesla's vehicle systems and future robot products will directly access xAI's core model capabilities. The significance of this change isn't just adding a feature. When systematically embedded into the hardware system, the boundary between software and device begins to blur, and the product looks more like it's continuously evolving under the same intelligent framework. The most intuitive change appears first in the interface. Future autonomous vehicles will no longer just execute commands, but will be able to understand more complex language inputs and make more coherent responses. But the deeper impact isn't whether it can chat, but rather, when a large number of devices share the same intelligent model, the system's overall learning and feedback methods are changing. Imagine this. When Tesla fulfills its promise in 2026 to deploy tens of millions of Robotaxis in 9 major cities like Dallas, Houston, and Phoenix, who will command this massive steel legion? Human dispatchers? Impossible. Traditional rigid algorithms? Too inefficient. Musk explicitly revealed Grok's other identity in the report. It will maximize the management efficiency of the autonomous fleet. This is a highly imaginative scenario. Grok will serve as the central brain of the entire driverless taxi empire, processing data from millions of vehicles in real time. It can not only plan routes based on traffic conditions, but also predict demand hotspots. For example, by analyzing social media and news, Grok knows there's a big concert downtown tonight. It will command empty Robotaxis to gather in that area an hour in advance. This global scheduling capability based on large models is incomparable to platforms like Uber or Didi, which rely on traditional algorithms. It is not just a driver, it is a commander with a God's eye view. In this model, every Tesla is no longer an isolated individual, but a nerve ending connected to the same superbrain. Furthermore, for the humanoid robot Optimus, Grok's importance goes without saying. Musk admitted that among the 3 major difficulties in robot R&D, the hardest isn't building dexterous hands, but real-world artificial intelligence. Most current robots are pre-programmed and can only repeat specific movements. But Optimus connected to Grok will possess common sense. For example, when you tell the robot, "I'm thirsty," a traditional robot might not understand. But an Optimus with a Grok brain will use semantic understanding to know you need water, then combine visual perception to find a cup on the table, walk to the dispenser, get water, and hand it to you. This process involves semantic understanding, environmental perception, logical reasoning, and task breakdown. Only a large language model like Grok can endow a robot with this kind of human-like general ability. Thus, The real significance of this $2 billion investment isn't the amount itself, but that it strengthens a critical path for Tesla, feeding model capabilities, hardware carriers, and real-world data back into the same closed loop. If you look at the entire AI competitive landscape, you'll find the advantages of each player are actually asymmetrical. Companies like OpenAI and Google lead in general model capabilities, excelling at processing text, images, and code, but they mainly run in digital environments. On the other side, some robotics companies have deep accumulation in mechanical control and movement capabilities, but lack high-level understanding of environments and tasks, relying more on preset commands. Tesla is trying to integrate these two ends, letting the intelligent model run directly on a real-world carrier and reverse-train the system through continuous usage data. This structure determines that it's not competing on single model performance, but on the evolutionary speed of the whole system. Only Tesla, through this investment, has completed the perfect puzzle of the strongest body plus the strongest brain. The data advantage brought by this combination is destructive. xAI focuses on training large models in the digital world, extracting all knowledge from the internet. Tesla focuses on collecting data in the physical world, recording the physical laws of the real world through the cameras of millions of cars and robots. When model capability and real-world data are placed in the same system, change begins to appear. Through the sensors on vehicles and robots, Grok can continuously touch the real environment. Conversely, autonomous driving systems and robots can also leverage the model to gain a higher-level understanding of human behavior and scenes. This bidirectional feedback is hard to achieve by just doing models or just doing hardware alone. Just as Kathy would reflect it afterwards, she had previously underestimated Tesla's speed in advancing humanoid robots because she had incorporated this underlying synergy into her judgment. The chemical reaction produced by this underlying synergy is precisely the variable hardest to capture in market pricing. When we are still discussing whether a single robot's fingers are dexterous or not, the speed of this cross-dimensional resource integration has already completely exceeded the coverage of traditional valuation models. Looking at single-point news or delivery data makes it very easy to generate cognitive bias. That's why we organized a Tesla 50x compute arbitrage manual internally to provide us with an objective viewing angle, filling in those underlying details easily ignored by the market. I've already put this manual in the comments section. Click to claim it. Right now, Tesla is connecting AI, humans, and the energy system via the interface of AI. This structural integration itself constitutes a system advantage highly dependent on internal synergy, not simply relying on single-point technological breakthroughs. But to make this system run stably on millions of cars and robots, the model itself isn't enough. It also needs a hardware foundation capable of bearing high-intensity calculation and real-time decision-making. This is also why the next-generation computing platform, the AI5 chip mentioned in the financial report, has become a key point repeatedly emphasized by management. Folks, you need to know that in the existing silicon-based world, there isn't a chip truly designed for physical AI. Nvidia's H100, while powerful, is designed for the air-conditioned rooms of data centers, born to process pure text logic like ChatGPT. Stuffing it into the trunk of a car or the chest cavity of a robot not only consumes too much power, but also still has microsecond delays when dealing with instantaneous reactions in the physical world. This is the underlying motive for why Tesla must develop the AI5 in-house. It's not to save money, but to break through physical limits. On the earnings call, Musk threw out a set of data sufficient to make the semiconductor industry tremble. Compared to Hardware 4, which is already deployed on a large scale in vehicles, the next-generation AI5 chip has improved raw computing power by 10 times and memory bandwidth by 9 times. But the most shocking part isn't these standard metrics, but a highly targeted breakthrough. On specific inference bottlenecks, AI5's performance has surged 50 times. Please pay attention to the term inference bottleneck. In the combat of autonomous driving, what truly decides life and death often isn't average computing power, but the instantaneous explosive power when facing extreme scenarios. For example, on a stormy night, with strong light beaming directly from the opposite side, a pedestrian in black clothes suddenly crosses the road. Existing chips might need zero point 0.1 seconds to reduce noise from the massive data and make a judgment. But AI5, relying on that 50-fold bottleneck breakthrough, can compress this reaction time to within the limit of human neural reflexes. Musk boldly asserted that just with the safety of the current HW4 FSD, it can surpass humans by 10 times. But with AI5, he is attempting to push the accident rate infinitely close to zero. This is a qualitative leap from assisted driving to absolutely unsupervised driving. This chip is actually the final key Tesla forged to completely remove the steering wheel from the Robotaxi. However, designing the strongest chip is just the first step. Another plan Musk revealed on the call truly exposed his ambition to rewrite the global semiconductor supply chain map. He extremely seriously pointed out that Tesla is evaluating the possibility of building a giant chip factory on home soil. In the semiconductor industry, this is almost seen as suicidal madness. As everyone knows, chip manufacturing is the jewel in the crown of human industry, the territory where giants like TSMC and Samsung have cultivated for decades. A car company actually wants to mess with wafer fabrication, but Musk gave a set of irrefutable survival logic. He is doing it not just for cost considerations, but out of extreme fear of future capacity. According to Tesla's internal calculations, when Optimus robots and Robotaxis enter the mass production stage of tens of millions, the global existing advanced packaging capacity simply cannot meet the demand. Musk bluntly stated, "Even if you count the best capacity of Samsung and TSMC, I feel it's far from enough for the future demand for chips." This is a typical Musk-style precaution. He predicts that in 3 to 4 years, global AI computing power will face an epic shortage. By then, whether it's Nvidia, Apple, or AMD, they will all be queuing up at TSMC's door. If Tesla doesn't want to halt production due to a lack of chips and doesn't want to hand its lifeline over to others, it must own its own money-printing machine. In today's increasingly fragmented global supply chain, ensuring the silicon lifeline is in one's own hands has become Tesla's highest strategy to guarantee business continuity. This is not just commercial competition. It is to ensure that under any extreme circumstances, Tesla's production lines won't stop due to some blockade on the other side of the Pacific. The depth of this vertical integration has surpassed the Ford of yesteryear and the Toyota of today, touching the very bottom layer of modern industry. At this point, we finally see the complete puzzle of Tesla Nvidiafication. This is not only a battle of technological routes, but also an astronomical economic calculation. And Wall Street's biggest current misjudgment is still using the logic of buying graphics cards to evaluate the company's costs. Nvidia's GPUs are essentially general-purpose computing units. To be compatible with various tasks, they retain a lot of redundancy. This is like using a Swiss Army knife to cut a steak. It can cut, but it's laborious and expensive. Tesla, on the other hand, is walking an ASIC path. AI5 is custom-built for FSD's neural network transformer architecture. It strips away all unnecessary transistors, keeping only the purest matrix operation units. Under the same computing output, the energy efficiency ratio and cost advantage of ASICs are several times or even tens of times that of general GPUs. Think about it. If Tesla wants to produce 100 million Optimus robots in the future, and if every robot is stuffed with an Nvidia graphics card, the cost could be tens of thousands of dollars. This would directly kill the commercial viability of the robot. But if it's the in-house AI5 chip, as scale effects are released, the marginal cost can be compressed to a few $100s. This is Musk's confidence in not working for Jensen Huang. In the AI era, computing power isn't just a cost item, it's a long-term capability. Tesla is attempting to put algorithms, chips, and production capacity into the same system. Models come from xAI, chips come from in-house platforms, and computing power construction no longer relies entirely on external supply chains. The core of this choice isn't just lowering procurement costs, but increasing the certainty of acquiring computing power. When computing power becomes a scarce resource, whether one can sustainably expand computing capability itself constitutes a competitive advantage. In contrast, the model relying on a single supplier is more easily restricted when supply is tight. If we have already seen clearly Tesla's autonomous layout in software and hardware, Then next we must return to a more realistic question. How should these changes be reflected in valuation? Continuing to use only traditional P/E ratios or car sales growth rates to measure Tesla might no longer be sufficient to cover the business boundaries it is currently expanding. The problem isn't whether these metrics are right, but whether they are still complete. There is a piece of data in the financial report that is extremely counterintuitive. Tesla's projected capital expenditure for 2026 will reach a record-breaking $10 billion. This is a new high in Tesla's history, almost reaching a massive leap over the previous highest year. In the logic of traditional automakers, such a huge investment usually means building new car assembly plants, stamping workshops, or paint production lines. But this time, the flow of funds has undergone a fundamental shift. This $10 billion isn't used to build shells, but to build a hotbed for silicon-based life, buying chips, expanding data centers, setting up robot production lines. Here, let's introduce an extremely exquisite computer term, bootloader. Before an operating system starts, a small piece of code is needed to load the core system. After the task is done, it retires. The current market consensus is trending towards a brand new judgment. Tesla's massive automotive business is essentially that bootloader. Those millions of electric cars running on the road. Their ultimate meaning of existence is no longer simply to sell cars to make money, but to obtain massive cash flow and data through selling hardware, thereby providing fuel for Tesla's next stage of AI explosion. This also explains why, under the pressure of price wars and subsidy withdrawals, Tesla can still maintain about $1.4 billion in free cash flow and push cash reserves to $44.1 billion. The significance of this cash isn't just a safety cushion, but the ability to provide continuous investment for the new directions the company is pushing. Currently, the auto business is still a stable source of cash, and this cash is being continuously poured into long-term projects like xAI and Optimus. This change in capital flow means the company's focus is shifting from single manufacturing efficiency to longer-term technology platform construction. Against this backdrop, evaluating Tesla simply around delivery numbers or short-term gross margins can hardly cover the business structure changes currently unfolding. To reinforce this shift, Elon Musk announced on the earnings call that the company plans to stop production of the Model S and Model X in the second quarter of 2026. This is not an emotional decision, but a trade-off based on realistic capacity. These two models sell about 50,000 units a year, occupying production resources but contributing limitedly. The vacated production line space will be reallocated to support the manufacturing needs of robot-related projects. From a resource allocation perspective, this looks more like a recalculation regarding factory space. Using the same factory floor area to produce Model S/X yields limited annual revenue scale. But if switched to a robot production line, even estimating conservatively on unit price and shipment volume, the potential revenue volume is completely different. For management, this isn't a sentimental trade-off, but a choice of capacity efficiency. Precisely because of this, Tesla is concentrating limited resources, capital, land, electricity, and computing power into directions with greater return elasticity. This means the company is no longer trying to maintain all historical businesses simultaneously, but actively abandoning parts with lower marginal contribution, shifting the center of gravity to robots and AI-related projects. At the same time, another support point underestimated by the market is emerging: energy. Energy storage products represented by Megapack continue to see delivery growth. Gross margins maintain a high level and have already contributed stable cash flow to the company. The existence of this part of the business gives Tesla stronger financial buffering capabilities when pushing long-term investments in AI and robots. When the infrastructure is laid out, when factory space is shuffled into place, Tesla's business model will welcome the ultimate qualitative change, from one-time hardware sales to continuous high-margin software services. In this financial report, Tesla broke precedent and announced a key figure for the first time. The number of FSD subscribers or purchasers has reached 1.1 million. The disclosure of this number is by no means accidental. It is a carefully designed signal aimed at forcing Wall Street to start modeling the FSD business separately. Before 2024, FSD user growth was slow, but after the release of FSD v12, user numbers showed explosive growth. If calculated based on existing 330,000 monthly subscribers paying $99 per person per month, the annualized revenue from this item alone approaches $400 million. Please note, this is pure software revenue, with a gross margin of almost 100%. But this is just the appetizer. The real main course is the Robotaxi. The report revealed that the unsupervised version of Robotaxi will cover major U.S. cities in the first half of 2026. Once this model works, Tesla will no longer just earn money from selling cars, but earn travel service fees. It is estimated that when the profit generated by 1 or 2,000 robotaxis can account for 5% to 10% of the company's free cash flow, the market's valuation will undergo a step change. Fundamentally, this is a problem of the valuation system. Traditional manufacturing usually only gets a P/E of 10 to 20 times, while high-growth software and service businesses often correspond to higher pricing. As the proportion of software services and platform-type revenue in Tesla's profit structure gradually rises, the market will naturally readjust its expectations for it. This is also why Cathie Wood and her ARK Invest focus not on short-term delivery data, but on autonomous driving scale and robot application scenarios in a longer cycle. If the past Tesla was mainly seen as an electric car company, then now it is being re-understood as a platform-type enterprise simultaneously covering computing power, energy, and robot applications. Investing in xAI, developing in-house chips, adjusting capacity structure. These actions are not isolated events, but resource reallocations unfolding around the same goal. For investors, the key lies not in the sales fluctuations of a certain quarter, but in whether the center of gravity of the company's future profit sources is shifting. Seeing this point clearly is more important than repeatedly correcting short-term model parameters. Cash flow from the traditional manufacturing sector is being directed into underlying computing power and autonomous chip R&D, attempting to complete the role switch from a hardware supplier to a general artificial intelligence infrastructure giant. For us, trying to capture the trajectory of the leap from manufacturing to computing power hegemony amidst complex financial figures, relying only on fragmented interpretations often leads to huge cognitive bias. That's why we organized a Tesla 50x compute arbitrage manual internally, which can help us restore the systemic game hidden behind technical indicators. I've already put this manual in the comments section. Click to claim it.